All right, so we're going to talk about motion, and something that I want to point out today actually is when we talk about motion, we're going to be talking about height versus time. And in this particular picture, I hope you can see some, you'll notice that we're going to talk specifically about a Ferris wheel. Now the Ferris wheel is 30 feet off the ground, meaning from here to here, that platform sits 30 feet off the ground, if that makes any sense. But we do have a radius that goes from here out. He's the spokes, right? That reaches from the shaft way out to where the people are. And the height of this guy is 550. So I'm noticing in my video that it's hard to see, but this says 550 way up here at the tip top. This says 30 way down here at the bottom. And each of these are going up by 100s, up like this. So if the highest this Ferris wheel goes is 550, that's the person that's at the very, very top. And the lowest that person goes is 30 feet. What we'll notice is that this person over time is traveling from 30 feet because he gets on the ride. And then as the ride goes on, he gets way, way, way up to the top, like at 550 feet. And then as the ride keeps going, he'll come back down. And that will take the full amount of time. That takes us all the way around and around our circle. So if we get to continue this, this wave will continue to move forward. So we need to figure out what the radius is. We need to figure out all of the different parts for these wave equations that we've talked about. How do you find that radius, I wonder? Well, one way to do that is to say, wait, so the distance between 550 and 30 is 520. Yeah? Well, the radius has to be halfway between those two. So we're going to take 520 and divide by 2. That gives me 260. So my radius from here to here, from the center, the shaft out, would be 260 feet is what we're talking about here. 260 feet. However, that doesn't tell me how far off the ground we are at all times. See, from the shaft straight down, right there, we're going to say that that's 260 because that's the radius plus another 30. So from the shaft down, straight down to the ground is 290 feet. Yeah. So if I ask you to write an equation, these are the things that we're going to need to know. Oh, I meant to mark this. So 290 feet, that's going to be right here. Right through there. Okay, so what we need to know, or what we do know then, is that from our shaft way up here, that length is 260. And from here down to the ground, that length is also 260. Well, if you guys remember, when we go to create an equation, that first number right here is the amplitude. The amplitude is how far from the middle to the tip top or how from the middle to the very bottom it is. So in this case, it would be 260 feet. Well, this shape right here is an upside down C. So we need upside down. That's where our negative comes from. And that's the cosine of the whole guy, because C shape is a cosine guy. All right. Then we'll get to period in just a minute. And then what you'll notice is the next thing that I need to worry about is the midline. Well, the midline happens to be where that shaft is. And in this case, that is at 290 feet off the ground. So that's where we get our 290, our midline. The period right here that we're going to talk about is one whole cycle, or 2 pi, is going to be divided by how long it takes us. Now, it's hard to see, I realize, on your video, but each of these is 100, and he ends way over here at 1800. So 2 pi divided by 1800 will give me the period when I multiply that by t, because t is the time that we're talking about. So our equation for this particular picture then would be y equals negative 60t, or 60 cosine, parentheses, 2 pi over 1800 t plus 290. Now you can simplify that 2 pi over 1800 and make him pi over 900, because both of those divide by 2. But everything else would stay the same. Either form would give you the right answer as far as an equation for that particular guy. So what I've done is on your Canvas, you'll see this particular assignment right here. If you would, pause that video and print this out, because then you don't have to write down all of the words, but that's an idea for you to use, because those are the kinds of things we're going to talk about today. All right, so this is what we're talking about today. Okay, so whenever we do a word problem, the first thing I'm going to do is create a sketch, then I'm going to graph, and then I'll answer some questions, because I like to see the graph and the sketch. It helps me answer the questions. A Ferris wheel rotates at a constant speed, so we probably need to start with a wheel of some sort. There he is, super important right there. The wheel's radius is 10, so let's mark from the center, or the shaft, out, that's 10 meters. And the bottom of the wheel is 2 meters above the ground. So from here to here is 2 meters. That makes sense? So Darlene just had gotten on a pod on the wheel. So here's her pod, her spot right there on the wheel, and the ride starts at time 0. So the minute she gets on there, then they start to time it, and it takes her 15 seconds to reach the top of the wheel. That means from here all the way to the tip top is 50 seconds. All right, that's super interesting. Okay, so now I've got kind of a sketch, a kind of wheel of what we're going to do. That takes care of part 1. Part 1 is to make a sketch. So again, this is directly off this paper. Number 1, make a sketch of this situation. But then I want to jump down to number 4, because number 4 asks us to create a graph, and I think it's easiest to create the graph and then answer the questions after. So here we go. There's my graph. Super fancy right there. What I know is that this right here, this is going to be the meters, how tall this is going to go. And this is going to be the seconds, or the time that we're going to talk about. Okay, there's other things that need to happen here. For example, I know that we can't, that once we start, the lowest that we'll be able to go on this particular ride is 2 meters. Now the highest, if you come back to our sketch, or I lost the color. I'll find it in a minute. Okay, from here to here is 10. From here to here is 10. And then there's another 2 feet. So that would be 2 plus 10 plus 10. So the highest that we can go is going to be 22 meters off the ground when we're on this ride. Okay, and then we're going to talk about, I know that this shaft, this center, is going to be halfway between these two. So 22 minus 2 gives me 20. Oh yeah, and the middle of that would have to be 10 this direction and 10 that direction. So 10 plus 2, that means this has to happen at 12 meters, that midline right there. So again, that means because this and this have to be the same for that midline to happen. Oh, look, that's the same as my radius. So my amplitude will be the same as my radius. My midline then will be what takes me from the center straight to the ground. So 10 plus 2, that will be my midline, that 12. Okay, so what we know is that, the other thing we know is that it took Darlene 50 seconds to reach the top. So we're going to put 50, and we know she's at the top there, which means that the whole cycle, one cycle, is going to be 100 seconds. So halfway between here and here will be 25 seconds. Halfway between here and here will be 75 seconds. That helps me sketch my graph some, because I know Darlene starts at the lowest point at 0 seconds. At 25 seconds, she should be halfway up to the very tip top. At 50 seconds, she's up at the very top. 75 seconds, she's starting to come down. And 100 seconds, she's down at the bottom again. So this is our graph right there. So like I said, I like to make a sketch, then I like to do the graph, which then helps me answer some of the questions. So question number 2 said, what is the minimum height above the ground that Darlene reaches? Well, the minimum we've already found is going to be 2 meters. What is the maximum height above the ground that she'll go? So if that's 2, the highest height is right here at 22 meters. So on your assignment, or on this note paper, that's problem 1, make a sketch. Problem 2, the minimum. Problem 3, the maximum. Problem 4, sketch a graph. And then we're going to turn the page over, and we have more questions. I'm going to keep this near, but we're going to have more questions. Number 5, what is the amplitude of a function you sketched? Well, the amplitude then is the distance from the midline up or from the midline down to the very top or to the very bottom. Well, this change right here, we already discussed, is 10 meters. So we're going to put 10 meters here. The amplitude, again, by the way, is always going to be the radius for us. Okay, the period of the function you sketched means how long did it take you to go through a whole cycle? Well, in this case, it was 100 seconds, you can see. So we've got 100 seconds. Great. And then it says, what principal axis? Now, in class, we actually haven't used that word, but an axis is the place where he turns. We've been calling it the midline. So we're going to put the midline. What is the midline? So coming back here, our midline was right here. That happened at 12 feet. So then it asks us, write an equation that models the situation using the sine function. Well, I'm going to change that because this isn't a sine graph. This is a cosine graph. So I'm going to change that to a cosine function. And this is how we're going to start our equation. As always, we're going to start with y equals. Now, in front is supposed to be our amplitude. We found that the amplitude is 10. But because our C shape is upside down, we need to make this a negative 10. So negative 10 cosine. And then here, we're going to put our period. Now, remember, the whole thing around is how far we've gone. Well, we went a whole circle, so 2 pi, in 100 seconds. So 2 pi divided by 100 is what we're looking at, times t, because t is the time that it's going to take us, plus our midline, which is 12 from here. This is the equation that we need right there. Okay, now to answer some of the questions that we have, I want you to make sure that you are in radians. Why radians? Because we're using this 2 pi guy. That 2 pi guy tells us that we need to be working in radians. So if you haven't yet, on your calculator, make sure that your mode Oops, let's turn it on first. That would help. Make sure your mode is down here in radians. That radians is highlighted and ready to go. Maybe if I show it like this. There he is. Okay. And not degrees. That will help you immensely. All right, so what we're going to do then is go through just a couple other questions that we might have that might be interesting. That answers all of the questions on this particular page right here. So let's look at a few others that might be interesting. Okay, a Ferris wheel has a radius of 35 meters. So I'm going to start again by making a sketch. And the radius was 35, it says. So that means from the center out. Okay, if they say diameter, diameter is all the way across, but radius comes from the center out and starts 2 meters above the ground. So that's kind of like the other guy, 2 meters above the ground. Great. And rotates once every 53 seconds. That means if I start at the bottom and I go zipping around over here, that takes me 53 seconds to get around. Okay. So now, after we've done this, I would like to go ahead and make the graph. So this one asks me to sketch 2 complete cycles of the graph, is what they ask. So I'm going to go down here and do that. Let's see. 2 complete cycles. Well, I know that the first cycle is done by 53 seconds, so the second one would have to be 106 seconds, right? I also know the lowest that I'm going to go on this particular ride right here is going to be 2 meters off of the ground. But the highest, you'll see we've got 2 meters here. From here to here is 35, and from here to here is 35. So we have 35 plus 35, that makes 70, plus 2 more, that's 72. So the highest that we're going to be reaching here is 72 meters off the ground. That seems pretty fast and pretty high, is what's going to happen. So where's our midline? Well, our midline will happen where the shaft is, right there. Okay, well that's 2 and 35. We just discussed from here to here is 35 meters. This is 2 more. So that will happen at 37 will be our midline. Doing like this. All right, which means that our graph, make him in blue, if we start at the very bottom, we'll go here. He has to finish. He'll be there. He'll finish there. So where's everybody else? Oh, let's see. This is what we're going to do. There. So I'm going to take that 53 and divide by 2. That'll get me halfway through. So 26.5 is the highest. From 53 to 106 is another 26.5. So I'm going to take 53 and add 26.5. So the next highest is at 79.5. Okay. So this is what it'll look like. We'll hit the midline halfway between here and here. So we're going midline, tip top, midline, very bottom, midline, tip top, midline, very bottom. All right, that's my graph so far. Part A then says determine the cosine equation. Oh, see, now I have a graph to determine the equation from. So that's what we're going to do. I've got y equals, and then my amplitude, from here to here, how long was that again? Oh yeah, from 72 to 35 to 37 was 35. So I've got 35 cosine. And go ahead and put a negative in front because this is an upside down C shape. So I've got negative 35 cosine. Here is our period. Remember, we've made a circle in 53 seconds for each time we go around. and our midline is 37. So that's super helpful. All right, now we get to ask some important questions. What is the height of the rider at 81 seconds? I don't know. 81 is here-ish, so he's up quite a bit, but I don't know exactly. Well, that's why we have an equation. See, what we know is that t is going to be time. So we can plug into our calculator negative 35 cosine, parentheses of 2 pi over 53, and the time is 81 seconds, like this, plus 37. So that will go in the calculator. So again, make sure that you are in radians, because that's what we're working with. And then we'll go ahead and plug in negative 35 cosine, and they give you parentheses. Inside there, please put 2 pi divided by 53, like this. Oh, there we go. Now you can see it. Times 81, and put parentheses around that whole thing right there, behind what's in cosine there. Okay, and then we'll add the 37. That can go straight into the calculator and output 71.44. Oh, 71.44. Oh yeah, height. I guess that makes sense because at 81 seconds, I should be close to the top. I'm not exactly at the top. So 71.44 meters off the ground is where we are. Or 71.4, I'll take that too. So here's the really exciting question, D. At what time does the rider first reach a height of 51 meters? Wait a minute. That's not a T kind of a position. That's a height. That's the H position right here. Oh, goodness. So we're going to put right here 51 into our Y. And we've got all of this to work from. The problem is we have to solve for T. And T, you can see, is in the middle of absolutely everybody. So we have a lot of work to do. Well, the first thing we're going to do is move that 37 over. So we'll subtract 37 from both sides. So I've got 51 minus the 37, and that gets me 14. So now I've got 14 equals negative 35 cosine of 2 pi over 53t. Oops, parentheses around there, not there. Now here's our trouble, is that t is still in the middle of a whole bunch of stuff. However, negative 35 is being multiplied to all of that stuff. So if we divide by negative 35, now we've got, I'm going to put it over here, 14 divided by negative 35 equals cosine of 2 pi over 53 times t. This is cohead. This does not look even better. I'm not sure about that. See, the next thing we have to undo is this cosine. How do we undo a cosine? Well, we don't really, but we can take the inverse. So if I take the inverse of cosine, so cosine was here. If I take the inverse, they cancel each other out algebraically, I guess you could think of it. And this is what we'll be left with, which gets us super close to where we want because we're trying to solve for t. T is being times by 2 pi over 53. So what happens if we multiply by the reciprocal? There we go. That's the word I wanted, reciprocal. Because this will cancel, this will cancel. We'll be left with t. Woohoo! Finally! T is all by himself. Oh, what a mess. Here's the best part, though. That mess can go in the calculator. So what we're going to do is put in our calculator 53 divide by 2 pi. Please put parentheses around 2 pi if your calculator doesn't do fractions. And then you can do cosine inverse of 14 divided by negative 35. Make sure that says negative. Okay, so this is what my calculator looks like so far. And then I'll go ahead and hit enter, and out pops 16.72. Oops, there it is, 16.72. Wait, so T is 16.7 seconds? Wait a minute, wait a minute, wait a minute. Let's see. So 51. Oh, this happens more than once. Oh, I guess that makes sense because it happens here, happens here, happens here, happens here. So how do you find all of those? Well, the first one is the 16.7 places right there. The next one, you could take 53 and subtract 16.7. Whoops, what is it, 53? And that gets us right here at 36.3. Then it happens here, so you could take 53 and add 16.7, which gets us here at 69.7. And then one more time, you can take 106 and subtract your 16.7, and that would be at 89.3. So that will happen over this 2-cycle period 4 times. Once at 16.7 seconds, once at 36.3 seconds, 69.7 seconds, and then again at 89.3 seconds, because we keep hitting it.